thank you to Fernando for the next 30 minutes and his talk. Thank you.
Thank you. Yeah, thank you, everyone. Good morning. Guten Tag. I hope I pronounce it correctly, because my German is actually very limited. It's my first time here on the stage of adaptTo. It's actually my first time at a conference, my first time in Berlin, my first time in German. I actually need to register this unique moment. Just one more, please. OK, let's see. Yeah, I'm gonna share this picture with my teammates in Brazil. But they are probably always sleeping right now, because it's probably about 6 a.m. now. But anyway, in today's presentation, I'm gonna show you an internet-scale content management with Apache Oak running on Kubernetes. So my name is Fernando Saito. I work for HP R&D Labs in Brazil. And Galo Gimenez is the architect of this whole crazy ideas here. Content is a key enablement for many HP devices. Being it 3D printers, multifunctional devices, high-speed commercial printers, as well as immersive-enabled devices, such as the HP Sprout. HP is in the business of transforming digital content into physical objects, as well as physical objects into digital contents. And these digital contents can in many forms. It can be 3D modeling, it can be print jobs, it can be scanned documents, other sort of documents, and others. The name of the system of our content management, internally, we call it SDM. It's a secure document management platform. And it allows ADP device applications and services to access and store their content. It supports 65 million connected devices and an average of 50,000 documents operations per hour. At the core of SDM, it is Apache Oak. Apache Oak was our natural choice, I may say, because of its scalability and performance capabilities. Around Apache Oak, we created a set of other features, and we enable this access to the systems through a REST API. The SDM itself, it does not provide like a user interface. That user interface is actually provided by the services and applications that are connected to SDM. We also enable authentication and authorization, encryption of the content at rest, metering, and auditing. And all of these contents is actually federated content. We store all these contents in the cloud, in a cloud storage. And we actually have what we call two types of federated content. One we call it internal, and external. An external is actually enables to get access to content stored in repositories such as Box, Dropbox, Google Drive, OneDrive, and others. Right? I will go into some more details in the next slide. In order to explain how this federated content actually works, I will start describing how it is structured in our system. At the top level, you can see that there's the tenant. SDN supports multiple tenants. Every tenant can have many users. Every user provisioned into the systems actually have a set of predefined folders created. One of those folders is a root folder. And it is created with what we call a shortcut. A shortcut is pretty much like a friendly name to access a node ID. Right? In this diagram, you can notice there are those doc.pdf and myjob.pdf, right? So those are considered internal federated content. So they are actually encrypted and stored at rest in S3 buckets, right? In order to do that, we actually create our custom data store. So we call it cloud data store that allow us to encrypt this content and upload those contents in chunks to the S3 buckets. The orange, kind of reddish bullets there is what we call mount points. So those are customized JCR node types that we register into the system and allow us to access the external repositories. So it pretty much have a data abstraction layer that allows us to call through the REST API of each external repository and handle those documents on that external repository. So from the user perspective, the REST API itself, either to access the internal or external federated content is the same, actually. The only difference in order to access the external repository is an additional step that goes through the OAuth 2 workflows to actually connect and authenticate to the external repository. The rest is exactly the same, so it's sorry. Yeah. So all of this system we run on the Kubernetes clusters. So Kubernetes supports stateless and stateful workloads. So I will just highlight some of the Kubernetes features that we use it here. Maybe I should go back a little bit. So Kubernetes, it's an open source system for automating deployment. So scaling and management of containerized applications. So Kubernetes Stateful Sets is one of its capabilities that you use it. So it's designed to support stateful apps, such as MongoDB and Oak, right? It provides a consistent and permanent networking and storage. It also provides order starts of the components that are required, for instance, in order to deploy MongoDB web cassettes. We also use Kubernetes Federation. So through the Kubernetes Federation, it provides a single API to access multiple Kubernetes clusters. So we have our deployments into multiple data centers, into multiple clusters, and we use federations for that. But it's not only about Kubernetes and federation, right? In order to deploy and provide the level of automation that we wanted, we had to create custom tool sets, right? I will just list two of those here. Internally, we call those projects the Heisenberg and Pinkman, as you can see there. Yeah, that's because we like Breaking Bad, right? So the Heisenberg is pretty much about the pipeline, templates, and shared libraries that we use in our Jenkins server. Our Jenkins server is called Superlab. So the usual flow here from the developer perspective, he commit their codes, he create those benches, he push those pull requests, and every commit they made, it actually will trigger a pipeline job execution. So we use Jenkins too, and literally with all the pipeline abstractions that Heisenberg provides allow us to have like a Jenkins file with like a single line of code, actually. So in this single line of code in the Jenkins file, he just mentioned, for instance, I want to use the service template, or I want to use the library templates. And all the abstractions that we created will actually execute all the pipeline stages properly. For instance, it will check out the code, it will build the code, run unit tests, run stat code analysis tools, deploy the tool, run the functional tests, report coverage reports, run performance tests, integration tests, promote it to release, UP data staging, UP data promotion, production, I mean, and so on. So the Pinkman, on the other side, is most around enhancing our deployments tool sets. So it's pretty much like an abstraction on top of the Kubernetes API. So with that, we can actually enhance our deployments with annotations, for instance. So we can add annotation modifiers into our YAML files, for instance. So that allows us to have configuration specific for different regions and for different environments, for instance, right? For instance, a dev deployment, we don't need we can have actually use more restricted resources in order to run it, right? So we can restrict the CPU uses and we can restrict the memory consumptions on a dev deployment. And all of that using the annotation modifiers. So with all that, with Kubernetes, with all custom tool sets provided by Pinkman, by Heisberg, and by Jenkins, for instance, allow us to perform a global deployment of SDMs. So we deploy into multiple data centers across the globes and multiple regions automatically. So how is I will go into details about the customer experience here, how a user of our system actually interact with it. So when a user signs up to an HP application or services, well, their data will actually get stored in the data center that's appropriate based on global data compliance policies. So these are actually implemented by our service mesh. So service mesh is pretty much like an infrastructure layer that provides reliable, fast, and secure service-to-service communication. So this is supported by functionalities such as authentication, by policy enforcement, traffic management, and telemetry, right? So in this example here, you can see like 3 different data centers and 3 different users. So each of those will actually sign up to an application through a global vanity URL. So, and their data will be stored in their appropriate data center. So Jen's a user in US, so she'll have their data stored in the US data center. Galo, it's a user in Europe, so use the Europe data center, and Fix, it's in Asia, so you have their data and Asia data center. So, but what happens, right, when a user travels to another region, right? The GeoDNS itself, it will still keep redirecting to the closest data center. So, for instance, in this example, Jen, she traveled to London, but she actually had her data stored in the US data center, right? So the GeoDNS redirects her request to the Europe data center. But through the compliance rules, we actually locate where her data is actually stored. So her request is actually directed to the US data center. This same routing capability, we can actually use it for other use case scenarios, such as we can have multiple instances with different versions of the system and redirect part of this request to a specific service instance for testing purpose, for instance, right? Going to a little bit more of detail how this routing and discovery location actually happens. So we had 2 major parts here. One is the router, which is an IPG Edge Micro Gateway component running in a pod along with the services. And we have the Entity Location Services, the ELS. ELS, it's open source, right? So it's publicly available there in GitHub repository. So the router responsibilities and capabilities can be enhanced by plugins, right? So one of these plugins will actually extract the routing key that's provided along with a token that is sent with a request, and will perform a discovery stack request to ELS. DLS is integrated with a DynamoDB data center that's globally replicated, so it stores informations about metadata for each services. So the services actually update DLS with their metadata, and also we run consistency checks periodically. There's pretty much two approaches, the two routing approaches that we use. There's this, what we call the client-side routing and the server-side routing. So on the client-side routing, the client itself will perform actually two requests. One is a discovery request, right? So it will have the proper location where the data is stored before performing the actual data request, right? And there's the server-side routing where the client just send, well, give me the data. So it just performs the request data, and the system performs and abstract the discovery of where that data is actually stored. This is more of a reference, right? So a high-level architecture with the details of the parts, so you can that are involved in all this routing process. So you can see there the client performs the request, the GeoDNS, resolving that to the closest data center. You can notice the different pods running on the Kubernetes clusters. You can notice the routing pod, the service pod, the request being redirected, and discovery being performed by ELS, the DynamoDB replication, the request routed to the proper data center, and so on. So that was the current state, right? So what we are working on right now, we're actually working on improvements on our service mesh capabilities. So we are moving to Istio. So Istio, it's a service mesh that has a lot of advantage, actually. So I'll just highlight some of those. So Istio supports out-of-the-box Kubernetes injection, right? So, and it also supports out-of-the-box control plane. So in the previous approach, the EMG approach, there was just a single routing component, right? So in the Istio approach, that responsibility was actually split in the proxy and the mixer. So the proxy pretty much just extract the attributes and send those to the mixer for the proper rules, to apply the proper rules, right? So the mixer can enhance its capabilities with what they call the adapters. So there are the adapters for different purposes, such as auth2, analytics, versioning, coda, and mutual TLS. So the mutual TLS is actually guarantees the identity of the server to a client, as well as the identity of the client to the server, right? Another capabilities of the Istio is it allows us to apply rules in the ingress traffic as well as for the egress traffic. That's pretty nice, actually. What else? So this is how the Istio and its components considering the ELS. So we have, in the previous picture, you notice there was just a single router, right? So now the responsibility was split into the proxy and the mixer. And we actually create custom adapters in order to the mixer provide the discovery stack through ELS. The rest is pretty much the same, right? So this is the updated version of that previous diagram. So you can notice there the Istio components. So you can see the ingress, the proxy, the mixer, and the rest is actually the same, right? Yeah, that's a kind of very summary description of our solution and system, right? So you have time to provide questions. So thanks, Dank.
Thank you, Fernando. Any questions? There's one here in the front.
So thank you for the presentation. At some point in your slides, you mentioned that you have certain mount points in the repository that reach out to external systems. I'm curious how you implemented that. Was it at the Oak level, at the JCR level, your REST API level? Where is that mount point?
Yeah, the customization in Oak is regarding, actually, we just register a custom JCR node type that represent that connector, right, that mount point. But the actual implementation is pretty much on the application side, right? So we behave like a client of the external repository API. So that's pretty much about it. And in fact, we don't actually create like multiple clients, because we have another abstraction. We actually perform the access to the external repositories through Cloud Elements. So Cloud Elements, it's broker, right? So it actually simplifies a lot, and the access to all those different repositories. So we don't have to actually implement a client for every different external repository. We implement a single one through Cloud Elements.
Thank you. Any other questions?